My name is Raghav and the topic I have chosen for this science fair is Archimedes' principle. Why I chose this topic is because when I was going to swimming and got out of the pool, I realized that I felt a lot heavier, and when I went back inside the pool, I felt a lot lighter. And I wanted to know why this was happening. And I realized this is all explained in Archimedes' principle, which states when a body is immersed fully or partially in a fluid, it experiences an upward force which is equal to the weight of the fluid displaced by it. And now I'm going to demonstrate Archimedes' principle. So I have a spring scale and a sandbag, and if I weigh this in air, it says 2 Newton, which is equal to 200 gram. So and now we weigh inside water. And it says 0.8 Newton, which is equal to 80 gram. And to get our buoyant force, we need to subtract the apparent weight, which is the weight inside water, and the real weight, which is the weight outside water. And if we subtract these two, we will get 120, which is our buoyancy. And now we are going to calculate the displaced water, the weight of the displaced water. The empty glass says 32. And now it says 146. So if we subtract the beaker with water and the beaker without water, we will get 114. It's actually saying 114, not 120, because the spring scale is actually not accurate. It's only like an approximate, it only shows an approximate value. Now, why did Archimedes come up with this principle? There's actually an interesting story behind it. Once upon a time, there was a fellow named Archimedes who was born in 289 BCE in Syracuse, Sicily. One time, the king of Syracuse asked his goldsmith to make a crown for him, and when it was done, he suspected that the goldsmith had cheated him and used extra silver. But the king could not prove this, so he called in his most intelligent scientist, Archimedes, to help with this problem. At first, Archimedes did not know how to solve this, so he went to take a bath. So thinking about this, Archimedes went to take a bath in a fully filled tub. And when he climbed into the tub, he realized that some of the water was overflowing. And he also realized that the more he sunk into the water, the more water was overflowing. After realizing this, he jumped out of his tub and ran out in the street shouting, "Eureka! Eureka!" which in Greek means, "I have found it." And what did he find? He found the answer to the king's problem. Well, all Archimedes needed to do is get the crown and get a lump of pure gold and put them in 2 different cups. And if they displace a different amount of water, then the goldsmith has actually cheated. But what if the goldsmith only used 10% silver and 90% gold? It will be too hard to notice the difference between the two. So Archimedes came up with a brilliant idea. But I actually would show it to you, but I actually don't have a gold crown and a lump of pure gold. But I have 2 almost similar items that weigh the exact same. I have one rice bag and one sandbag. And if I put these in, the right distance, they weigh the exact same. And if we put it in water, we can see that the sand ball, since it's more denser, it's sinking, while the other is floating. Similar to this, the gold crown was afloat, while the lump of pure gold was sinking. And by this experiment, it actually proved that the gold squid was cheating. And that's how, and that's when Archimedes came up with this principle. But when we talk about Archimedes' principle, it's almost about buoyancy. It's actually about buoyancy. And when we talk about buoyancy, the first thing that comes to your mind are ships. And how do ships float? Well, ships are actually designed in such a way to displace a lot of water. And also to displace a lot of water that is greater than its weight. And most of the ships underneath is actually hollow. And also a ship has a curved bottom. So it increases its stability and helps it move forward and not tilt side to side. Thank you.